Okay, medians and altitudes. A median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So if we make a triangle, it has to go through the midpoint and go through the opposite side. Okay? So it's a midpoint, goes to the opposite side. Midpoint goes to the opposite side. Midpoint goes to the opposite vertices. Okay? Concurrency of medians of a triangle. The medians of a triangle are concurrent at a point that is 2/3 of the distance from each vertices to the midpoint of the opposite side. Okay. So let's look at some of these lovely pictures. Sean, if you could stop talking, that would be fabulous, sir.
You said Shauna?
Point of concurrency. It should be POC. I said Sean. Okay. So, if we've got this triangle, let's say A to D is 9. I'm just making this up. Let's see if we can figure out the other things. We know that medians go through the endpoints of our vertices of the triangle and the midpoint of the opposite side. We know that a median of a triangle are concurrent at a point that is 2/3 of the distance from each vertices. Okay, so if from here to here is 2/3 of the whole thing, what is from here to here, or we call that DP? If 9 is 2/3 of the way, what's the extra 1/3?
4.5.
Okay. All right. So A to P then, the whole thing would be 9 plus 4.5, right? 9, 10, 11, 12, 13.
Wait, hold on.
Yes.
It's 2/3. Wait, wouldn't DP be 3? If
2/3 of 9 is 3. So if AD was 6, DP would be 3, because 6 is 2/3 of 9.
Oh, I think.
Does that make sense?
I guess.
I really meant to put 6 there, because that would have made more sense. Okay. So we're not going to draw this and measure it right now for the bottom, so we're just going to go on to example 1. Okay, example 1. D is a centroid. Centroid is the point of concurrency for medians. D is the centroid. So, D to G, here's D, here's G. D to G is 4. What is B to G? Okay, is D to G 1/3 or 2/3, or the whole thing?
1/3.
It is 1/3 of G to B. So what would DB be then? If 8. And so the whole thing would be 12. Okay. If I know this is 1/3, okay, if I have 4 3s, how many do I have? 12. If I know D to B is 2/3 of the way, I know I have 2 out of those 3, and I have 8.
So essentially it is like 1/3.
Of the way from the sides, 2/3 away from the vertices. Okay?
Wait,
All right.
the centroid is 1/3 away from the sides and 2 sides.
2/3 away from the vertices. Yes, ma'am. Okay. Let's move on to the last one.
You just drew a line.
Okay. We have triangle ACB with medians E to B, G to A, C to F, and point of concurrency, or the centroid, as D. We know B to E is perpendicular to A to C. We we know that AB to CB is congruent. AB to CB is congruent. So this whole side, same length as this whole side. We know F to B is 5. We know E to C is 3. And we know D to F is 2. If D to F is 2, what is C to F?
4.
So we know D to F is how much? It's 1/3, right? So that means we'd have to have 3 2's to make up the whole thing, which would be 6. Okay, so here's a tricky one. What is the length of CG?
5.
We know FB is 5. We know the median's cut at the midpoint. Therefore, this has to be the same as this, and we know these two sides are the same. So we know it has to be 5. What is CD?
4.
You know that this is 2. You know that this is 5. Or you know that this is 3 and this is 2. So 2 squared plus 3 squared equals x squared. So 4 plus 9 equals x squared. 9, 10, 11, 12, 13 equals x squared. So the answer